Okay, hello. We are on lab number 3, and this is going to be the lab on tissues. So I have a PowerPoint for all the different tissues that we will have to learn. There's 13 of them. In your lab manual, we are on page 17. So if you take a look at page 17, objectives, be able to name the 4 tissues in the body, okay? And at the bottom of page 17, they have those for you. They are epithelial, connective, muscle, and nervous tissue. We'll be learning muscle tissue in a separate lab, nervous tissue in a separate lab as well. For this lab, our focus is epithelial and connective tissue. Be able to recognize and name the type of epithelium and connective tissue. Name the organ which is used in lab as an example of each tissue. Okay? In other words, where is this tissue located at? Learn the general characteristics of epithelium and connective tissue, and that's what we will start with before the slides start. So if you look over at page 18, we have 6 epithelial and 7 connective tissues. The location of each tissue is written to the right. You do not need to know the function of these tissues, which personally I think is abysmal. Lab should be structure and function, not necessarily structure, function, or structure and location, because location is part of the structure, so all you really learn is the structure. You almost can't learn the tissues unless you understand that how they are made, how they are constructed, lends to their function. In other words, structure dictates function. All right. Since you are getting a PowerPoint of these tissues, page 20 becomes obsolete, as well as page 21. All that's going to happen is you're going to get a slide, and someone is going to ask you, what is the name of this tissue, and where can you find it? Those are the only things that you need to know. All right. So we'll start on page 18, and I will start differentiating between epithelial and connective tissue. Also, in your textbook, all of this starts in figure 4.2. So looking at figure 4.2, 4.3, 4.4, 4.5, 4.6, and on until you get 13 different tissues, pay attention to that. Doesn't matter what version of the book you have or what edition, all of them is in the 4th chapter. All of them are in the 4th chapter. Starting with figure 4.2, maybe on different pages, but the figure numbers are still being relevant. All right. So I hope this lighting is working. I'll be able to play this back here in just a little bit. So before I do the tissues, I'll see if the light's good enough for us. So let's take a look at the relationship between connective tissue and epithelial tissue. Epithelium is always, there's a big white spot right there, isn't there? I think that's not going to work. Let me turn that off. We'll see if this works better. Should. Okay. epithelium is what we call the most apical tissue. That is, it's superior in its location to connective. Connective is the more basal located tissue. Basal, basement, bottom. All right? So apical, if you want to touch epithelium, we'll start with the mouth. If you roll your tongue across your cheek, you are touching epithelium. All right? Epithelium is always sandwiched or connected apically to connective tissue. Connective tissue acts like the foundation, if you will. All right? But there's a space up here which we call the lumen. So if we're talking about your mouth, inside the buccal cavity of the mouth, that would be the lumen of the mouth. And if you were going to move in, okay, just because you have something in your mouth does not mean that it is in you. Even if you were to swallow something, it's still technically not in you. All right? When you think about it, from your mouth down your esophagus, in your stomach, through all the intestines, and all the way to Uranus, okay? So from your mouth to Uranus, and that's a long way, like, it's like billions of miles. Oh, sorry. Wrong Uranus. All right. But anyway, basically from your mouth to Uranus, that's just a long tube. It's not in you, okay? We can't say that a substance is in you until it is absorbed into the circulatory system, okay? And that's where our connective tissue comes in. Turns out that the connective tissue is riddled with blood vessels. We say that the connective tissue is vascular. Okay? Have you ever been chewing something and you bit the inside of your cheek and you even hear it crunch in your teeth, and you bite down and you think, oh, I'm going to stick my finger in that, and you pull it out, you expect to see all kinds of blood, right? And you don't have any blood. And when you kind of think about it, it really didn't hurt that much. All right? What you did is you just bit into the epithelium. Okay? The reason it did not hurt is because epithelium is avascular. That means it is without blood vessels. And there are no nerves. Very little. Okay? Another time you bite into your cheek and you expect it, it's probably not even bleeding. You stick your finger out, you pull it out, it's full of blood. And when you run your tongue into it, it actually hurts. That is because you bit through many layers of epithelium and you actually invaded into the connective tissue where there are blood vessels, vascular, okay, with nerve supply. Okay? So these are the distinctions between epithelium and connective tissue. Okay? So when we get to the slides, I'm going to use the words apical, I'm going to use the words basal, all right, and the words lumen, okay? So epithelium lines all the cavities of the body, the mouth being the first cavity, the esophagus being the next cavity, the stomach the next cavity, the small intestine the next cavity, and the large intestine the next cavity, okay? There are other cavities in the body, but that will suffice in knowledge for what we're doing. And we actually continue along the GI tract for most of the locations of the epithelium and the connective tissue that we'll be talking about. All right? Man, I was going to use this one spot, and that's not going to work. I'm going to have to actually teach over here because I want to be able to show the slide with, how am I going to do this? I think I'll explain them in 2D as I draw pictures, and then leave the camera right here and erase it and show you that particular slide. I'll have to turn off and then turn on, turn off and turn on. All right, such is life. All right, we'll start with our first tissue, number 1. Okay, epithelial. Simple squamous epithelium. Okay, need to make sure you understand all 3 of those words. Obviously, we are talking about epithelium, and those other words. Let's look at the word simple. Simple means one layer. Okay, one layer of tissue. Squamous, the second word, describes the shape. Simple squamous epithelium is like this. One single layer. Okay? Kind of teardrop. Number 2. Simple cuboidal epithelium. And just as it says, one layer thick, and instead our cells are now what? Shaped like cubes. Okay? In other words, this simple squamous needs to be very, very thin. Okay? Needs to be very, very thin. You find simple squamous in lung, where you do gas exchange. And you want the thinnest layer of tissue there to make diffusion happen very easily. In other words, oxygen needs to be able to leave the lung and get into the alveoli, the air sacs. And the CO2 that's full in the blood needs to be able to leave the blood vessel and move into the air sac so it can be exhaled. So we need just a very thin layer. Simple cuboidal, this tissue is going to be, or it would have the necessity of being a little more resistant, okay, a little stronger. And we find simple cuboidal in kidneys. And in the glomeruli, where you're having your filtration going on, things need to be able to move in and out of the cells of the kidney, and simple cuboidal does just the job. Single layer, but since there's a little bit more pressure, a little bit more need for resilient cells, we go from squamous to cuboidal. All right. Number 3, simple columnar epithelium. And these are shaped just as you would think, like columns. I think the Greeks first started building with columns. I think Rome ripped them off, or vice versa. But anyway, columns. In the lung, don't really need a lot of strength. Squamous will do. In the kidneys, cuboidal gives us a little more rigidity. But where simple columnar is found, if you're looking in your lab book, is found in the small intestine. Specifically, the one that they're using is the jejunum. All right? The jejunum is the middle section of the small intestine. First you have the duodenum, the jejunum, and then the ileum. And of course, these cells exist in all three of those sections of the small intestine. All right. Would you agree that the small intestine is where we're going to absorb nutrients? So we only want one layer, but there is a lot of twisting and movement, peristalsis, all kinds of stuff like that. Need a hardier cell. So as you see, the type of epithelium used, depending on the location, you need to have hardier, and more hardier cells to carry out the functions of diffusion, filtration, moving across the membrane. All right, so let's take a look at those, and I'm going to erase these, and I will turn on. It's just the way it's going to have to be, so we'll be waiting for it to pop up. Takes time. Let me see how turning the light out will work. I keep checking the camera to find out when it turns off, when it turns on. Still got that spot. Huh. All right, so this is simple squamous epithelium found in lung, the alveoli. And you have these perfect round circles right here, not perfectly round, but they're round. You'll notice that some places the circles are not complete. Let's blow up the picture for you. Man, I just don't like that spot. I like showing, I think I want to do the computer screen. Got a better picture on the computer screen. Let's see. That just doesn't show very well. Huh. Probably show better. If I have to draw, I'll lift the screen up. See if that gets rid of our spot. Okay. We got a new projector, and I don't think it shows as well. We'll just have to live with this yellowing. All right. A little bit better view here. This is if you follow along in your PowerPoint, this is the squamous. And you have nuclei going all the way around here. This is the lumen. of the alveoli here, and the reason that you have squamous is because air is putting pressure on these cells, compacting them. So this is an example of simple squamous epithelium. Found where? Yes, in the lung. Next, the wide view of simple cuboidal. You can see all the white lumen right here, okay? Little white dots. Let's zoom in a little bit better. And finally, right where we need to, the lumen. And notice the cuboidal shapes. Now you're thinking, wow, everybody has a nucleus except that guy right there. Where's the nucleus? Well, when you slice these across, okay, you may cross right through the center where the nucleus is, and you may slice it high. This is not perfectly flat. So this nucleus is either below or above where the cut was, all right? But you can see cuboidal all the way around, and it shows up in your book as well. Here is the lumen, epithelium right here, okay? All of this is epithelium. So make sure that you're looking at all the different magnifications, and that you can find all of those magnifications. All right. My projector is projecting up a little high. Let me see. All right. So anyway, the jejunum, small intestine. All right. Good connective tissue all down in here. This is the lumen of the small intestine, and you see these finger-like projections. Okay, there's a finger. Okay, actually that's the glove. Inside is the finger. Okay, finger within a glove is how I like to express these villi. Okay, so those fingers that we're looking at, that is villus or villi. Okay. Let's pop in a little closer. Okay. Again, this white area is the lumen, and there's a lumen in between the fingers. Okay. In between the fingers. Okay. So, what is the epithelium? All this in the center is connective tissue, and then you have your columnar tissue. The picture in the book is deceiving because it's taken at a different angle, but this is what you need to see. Columnar cells going all the way around and up that way right there. Okay? So if you point right here, this is your epithelium. In the middle, the lamina propria, this is connective tissue. That's where the blood supply is. So little particles are trying to go from here into there, okay, into the circulatory system, to where it can be described as being absorbed and is now in you. Let's zoom this up so that you can see the columnar cells. Okay, just like that. Notice some of these opaque circular things that did not take up any stain. Okay, they didn't take up any stain. Those are goblet cells. And goblet cells expel mucus. Okay? Now, why would you want mucus lining the little alveoli of the intestine? Well, one, it helps trap food particles that need to be absorbed. And number two, slightly protective. Remember, food coming out of the stomach into the intestine is very acidic. So if this were the duodenum, you would see a lot more goblet cells. Okay, a lot more goblet cells. All right. Need to get back over here and do some more splaining. When it comes to simple squamous epithelium, simple cuboidal, simple columnar, nobody ever misses those. Okay, it's just easy to identify. So let's talk about the fourth, pseudo stratified. Pseudo stratified, ciliated, columnar, epithelium. Okay? Pseudostratified, ciliated, columnar epithelium. Okay? Pseudo means false, so falsely stratified. It looks like it's stratified, but it's not. Stratified would mean more than one layer, okay, multiple layers. So it looks like there's multiple layers, but there's not. The word ciliated means little hair-like structures, cilia, okay? Columnar, you already know that's a column, and of course this is still epithelium. So let me show you what that would look like if I were to draw a picture of it. I'll do one more. For the first time, the nuclei are not centrally located. This gives it the appearance of being pseudo-stratified, okay? But notice that this is just one layer thick, okay? Just a single layer. And one of the things that's on the apical side are these little hairs. Similar to the tails of a swimming sperm, these cilia beat back and forth, okay? Where do you find pseudo-stratified, ciliated, columnar epithelium? According to our textbook or our lab book, it's found in the trachea, okay? So the trachea, the lumen of the trachea is right here. And you have this cilia. What is that for? Well, let's go back over to our slide. I'm going to point and zoom in to where we need to be. All right, so you see that little arrow? This little band right here is our epithelium. What's all this? That's right, connective tissue. In fact, this connective tissue looks squeezy, like it could be squeezed, but what about this connective tissue right here?